The very first division of numbers is in two parts, real numbers and imaginary numbers. All the useful numbers are real numbers. Okay. Any number which involves a square root of a negative number is called imaginary number. Usually we know square root of -1 is equal to I, that I represents imaginary number. A little bit more about I square is equal to -1, I to the power 4 is equal to 1. So wherever I is involved, we'll call it imaginary number. Just one example, root of -9, it is equal to 3 root of -1, which is 3i. So this is an example of imaginary number. All the others useful numbers for counting, measurement, presentation of size, they are all real numbers. Real numbers have been divided in two categories, rational and irrational numbers. Irrational numbers are those numbers which can be presented as a decimal in the form of a non-terminating and non-repeating decimal. So actually any number which involves a square root which is not where the calculation is not possible to the exact terms, like root 2, root 3, cube root of 5, some special things like pi, e, exponential number, these are all examples of irrational numbers, or any combination of them, like 3 plus root 2, this is an irrational number, or 3 minus root 2 is also an irrational number. The numbers which can be presented in the form of either a complete decimal, pure decimal like 0.5, terminating decimal, or rather no decimal, 3 minus 4, or any number which can be presented as a recurring decimal like 1/3, 1/7. These are all rational numbers. That is why combined together they can also be presented as a ratio of p by q, where p and q also are rational numbers. So you cannot take root 3/2. Root 3/2 is still an irrational number. Just keep that thing in mind. Okay. Now rational numbers on the basis of their decimal presentation can be divided into two parts, fractions and integers. Right? Integers have zero fraction. Integers have no decimal. You can call it like this, no decimal. If a number has no decimal part, it is integer. If a number has a decimal part, it will be called fraction. That's the fundamental definition, right? Now fractions can be divided into two types, right? One type is proper fraction and the other type is improper fraction. Okay, improper fraction. Just one important thing, in the definition of rational numbers, when we said p by q, here it is important to mention that q cannot be equal to 0, alright, because it has to be a measurable quantity. So q cannot be equal to 0. For fractions, q cannot be equal to 1 in the most simplified form. So you can't say that 8/4. 8/4 is not a fraction because on simplification it gives us 2. So in the most simplified form, q cannot be equal to 1. Okay, and for integers, q equal to 1. That's what you can say. Now, for proper fractions, p has to be less than q. That is, numerator has to be less than denominator. For improper fraction, numerator has to be more than denominator. The numbers can be positive or negative both. If I call a proper fraction as f, then this value of f will be between -1 and 1, not equal to 0. Just remember that. Okay, and improper fraction, if I call it I, or let's call it f, capital F, that improper fraction value will be more than 1 or it will be less than -1, not equal to integers, right? So these are fractions. Okay, so in a way, you can also say that the proper fraction value is between -1 and 1, all the decimal values other than 0. Right, all the decimal values other than integers greater than -1 and less than 1, greater than 1 and less than -1 will be improper fractions. Now let's talk about integers. Now integers are something that are really crucial and important. So let's create some space here and also take a different color. Integers. Integers can be divided into parts in two different ways. One way is negative integers, positive integers. Here it is very important and imperative to understand that 0 is neither negative nor positive. Integers are those numbers which do not have any decimal part. So this is one way of dividing it. The positive integers are called natural numbers Negative integers do not have a specific name. 0 and positive integers together are called whole numbers. Okay, whole numbers can also be termed as non-negative numbers, right? Non-negative integers. There is one more way of dividing integers into two parts, and that is a very crucial and important thing, and that is like this. It is even numbers and odd numbers. Please understand the definitions very clearly. They're very, very important. For what are even numbers? We know that we say that the numbers divisible by 2 are even numbers. No, there is a correction there. That is only half the definition. Any number which can be presented as 2n is an even number, and one above even, one below even will be an odd number. So 2n plus 1 and 2n minus 1 is an odd number. Now here it is important to understand the words factor, multiple and divisors. So please note it down very clearly, carefully, and memorize it. Factor, multiple and divisors. These are the words which will be used only for positive numbers. Okay, only for positive numbers. That is why I said when we say even numbers are only divisible by 2, that means we are including only positive numbers. Whereas even numbers actually are both positive and negative, because here when I say integers, they should include all integers, right? Both positive, negative and 0 also. Okay, so that is why a suitable definition will be anything that can be presented as 2 into something is an even number, where n can be any integer. N can be positive, n can be negative, n can be 0. So if n is 0, right, 2n is 0. If n is 1, 2n is 2. If n is 2, 2n is 4. If n is 3, 2n is 6, and so on. If n is minus 1, 2n is minus 2. If n is minus 2, 2n is minus 4. If n is minus 3, 2n is minus 6, and so on. Right? So even numbers are positive and negative both. Similarly, odd numbers will be 1, 3, 5, 7, and so on. And similarly, minus 1, minus 3, minus 5, minus 7, and so on. So one very big mistake in terms of definition itself at that basic level people make, that is that integers are divided into two parts, even and odd. This is one complete way of division. Okay, and there is another way of division, that is negative, positive and 0. So in positive there will be even and odd, in negative also there will be even and odd. 0 itself is an even number. So just understand this definition part really clearly. Before we go ahead, let's talk a little bit more about even and odd numbers. There is some basic operation that should be absolutely clear. If you add any number of even numbers, even, plus even, you're always going to get even number without any doubt. Okay, but the problem is if you add odd numbers, then you need to know how many odd numbers. For example, if you take 2 odd numbers, their sum is going to be even. But if you take 3 odd numbers, odd plus odd, you're going to get odd numbers. So just be careful about these things. So 3 odd numbers or 5 odd numbers or 7 odd numbers. So odd numbers of odd numbers, if you add them, okay, just be careful. Odd number of odd numbers, if you add them, the outcome is always going to be odd. But if you take, 2 odd numbers, 4 odd numbers, 6 odd numbers, and so on, their addition is always going to be even number, right? So just be careful about it. If you subtract, okay, so even minus even, that is even. Odd minus odd is always even. So these two are always even. But if you take even minus odd or odd minus even, that is always going to be odd. Right, so just be careful of that. Simply multiply. If you multiply any number of odd numbers, odd into odd into odd, any number of odd numbers, doesn't matter. The outcome is always odd. Okay, but even one of them, even if one of them is even, right? So I take one even number and all the others odd, then their product is going to be even. So to make the product equal to even, at least one of the numbers that are being multiplied should be even. If all of them are odd, then only the product is going to be odd. Now let's talk about natural numbers. Now natural numbers can be further divided into two types, prime and composite. So let's take it one by one, right? Very important, prime and composite. I'll write composite later on. First, let's describe prime numbers. Prime numbers are, you have to understand, these are natural, that means positive, only positive. The definition is the number which cannot be divided by anything else. It can be divided by itself or 1. So in general we can say that the number which has only 2 factors is called prime. Only 2 factors, okay? Remember this. And what are those factors? Those factors are 1 and the number itself. There is no general expression. Now what do I mean by expression? When I say multiples of 3, they can be presented as 3n. Multiples of 2 can be presented as 2n. Whereas prime numbers cannot be presented in a general expression. And understand this 1 and itself also should be different. What does that mean? 2 is a prime number, 3 is a prime number, 5, 7, 11 and so on. These are all prime numbers. You know, what are the factors of 7? Can you see that? The factors of 7 are 1 and 7. Right? Only 2 factors. You don't take minus 1 and minus 7. Even if minus 1 into minus 7 is equal to 7, we don't say that minus 1 is a factor of 7. Minus 7 is a factor of 7. We don't say that. Why? We have already said the word factor is defined for only positive numbers. Then what is this? This is just a relation. This is just a mathematical operation. Product of 2 numbers, that is equal to 7. Right? So don't take negative numbers into consideration when you use the word factor, multiples, divisors and other things. Anyway, so the prime numbers are these things. Now 2 is the smallest prime number. 2 is the only even prime number. Only even prime number. All the others prime numbers will be odd. All other prime numbers are going to be odd. You have to remember this. Okay. Fine. Then there are some basic information that we can memorize. From 1 to 100, how many prime numbers are there? From 1 to 100, there are 25 prime numbers. Right? These are like ready reckoners. Smallest number is 2. Largest prime number is 97. From 1 to 50, from 51 to 100, you see, from 1 to 50, from 2 to 47, these are 15 prime numbers. Okay, from 51 to 100, the smallest prime number is 53, the largest one is 97, and these are 10 prime numbers. From 101 to 200, you can check 101 to 200, there are 21 prime numbers. I want you to check them, at least the first and the last one. Okay, now there are certain other things. The difference between prime numbers, if you see the difference between prime numbers, now this is one interesting area. You can see other than 2, if you take any other set of prime numbers, I repeat, other than 2, if you consider any other pair of prime numbers, the difference will always be even, which is obvious. These numbers are odd, so the difference will be even. Right? There are certain specific triplets like 3, 5, 7. This is the only triplet where the difference is 2, 2. Right? This is also called a triplet, simply a triplet. A triplet directly would mean this particular triplet, that is 3, 5, 7, where the difference is same. For any other 3 consecutive prime numbers, the difference is not going to be 2, 2. It is not going to be same. Alright? So this is how we can see. Now let's go ahead. The difference keeps on changing. Sometimes it is 2, sometimes it is 4. From 7 to 11, the difference is 4. From 89 to 97, 89 to 97, the difference is 8. If you check the prime numbers here in 3 digits, if 113 is a prime number, and after that the next prime number is 127. So you can check that the difference is 14 here. Alright. Now the second thing that we have is composite numbers. Okay, composite numbers are those numbers which have more than 2 factors. Very clearly, more than 2 factors. Right? So for example, 12, what are the factors of 12? 1, 2, 3, 4, 6, 12. Okay, why I'm saying more than 2 factors? Because if it has 2 factors, then it is prime. Right? If it has more than 2 factors, then only it will be composite number. So here the first thing that you need to answer is, what about 1? Is 1 a prime number? Does it have 2 factors? No. Does it have more than 2 factors? No. So it is non-prime, non-composite. So 1 is the only integer, 1 is the only integer which can be termed as neither prime nor composite. It is actually the king of natural numbers. Okay, so prime numbers which have exactly 2 factors, right? Composite numbers which have more than 2 factors. So actually the composite numbers identity would actually stand with its you can say number of factors. Okay, so the first thing that we need to understand is the factorization. About prime numbers we need to understand the factorization and then number of factors. Let's take it up in the next video. Now a little bit more on prime numbers. There is a special property for a prime number greater than 3. You need to understand this really carefully. For all the prime numbers greater than 3, that means other than 2 and 3, all the other prime numbers, 5, 7, 11, 13, 17, 19, all of them, they can be expressed as either 6k plus 1 or 6k minus 1. This is a really important thing to understand and remember. Okay, what does that mean? If there is any prime number which is greater than 3, if I divide that prime number by 6, the remainder for this, understand the process, the remainder is either 1 or minus 1. And what is the meaning of minus 1 actually? Minus 1 or 5. Okay, for example, you can check this 5 is 6k minus 1. I'll just list down a couple of them. 6k minus 1 format, you can see it is 5, 11, 17, 23, right, 41. These are the prime numbers. 47, which are of the form 6k minus 1, and there are millions others. Similarly, for the structure 6k plus 1, the prime numbers are 7, 13, 19, right, 31, and so on. These are various other prime numbers. Please understand that here the vice versa is not true. What does that mean? Vice versa is not true. That means if there is a number which is of the form 6k minus 1, will it always be prime? Just check it. There are certain numbers of the form 6k minus 1, like 35. Will it be prime? No, it is not a prime number. Okay. Similarly, there are certain numbers of 6k plus 1 structure. For example, 25. Is it prime? No, it is not a prime number. So don't apply it as to check whether a number is prime or not. You can't do that. What is important is if there is a number which is of the form 6k minus 1 or 6k plus 1, it may or may not be prime. Okay. But if the number is not of this form, it is definitely not prime. Okay. I'll write it here. A number not of the form 6k minus 1 or 6k plus 1 other than 3, greater than 3, okay, is definitely not prime. That is very clear. Okay, this is how you have to remember it. But if it is a prime number, then it has to be either 6k plus 1 form or 6k minus 1. Just remember that.